was the best of times. It was the worst of times. Yes, I know, but bear with me here. As engineers, our RTL design lives are really a tale of two separate places. On one side, we've got our EDA tools, our simulators and synthesizers and formal tools and so forth, fancy, high-dollar stuff. On the other side, we've got our tools that we maybe use more to get our real creative work done. You know, like spreadsheets and text documents. Definitely not fancy high-dollar stuff, but still a huge part of most of our engineering processes. The thing is, there is this huge wall between these two sides. What we need is a way to bring the domains together, to let us work in our plain, casual, comfortable sheets and docs, and use that to drive our fancy, structured RTL design environment. Hi, I'm Amelia Dalton, host of Chalk Talk. We need a far, far better way to get to high-quality RTL. My guest today is Anupam Bakshi from Agnisys, and we're going to talk about getting our design from specification into verified RTL. And before we get started, don't forget to click that link. There you can find out more information about IDesignSpec from Agnisys. Hi, Anupam. Thank you so much for joining me today.
Thank you, Amelia.
So everyone knows that the R in RTL design stands for register. But I've got to tell you, most design teams I know have a lot of issues in their design process that center around those pesky registers. So, Anupam, what kind of challenges do you see designers facing related to registers?
Right, so we're talking about addressable registers. Often there are too many registers in a system, and documenting them, specifying their functionality, their behavior, their special cases, it becomes tedious. There's just too much data.
Yeah.
There are often like thousands of registers in a system. And changes to that data or to the intended behavior of these registers can cause problems, because if those changes are not communicated to the various teams who depend on that data, there can be bugs in the system.
Sure.
And this can be a significant source of bugs because there are so many registers and there are so many fields in those registers.
Right.
Things like mismatch in specification and implementation, registers at wrong address, or even wrong description. Something as simple as that.
So, Anupam, I do hear those kinds of things from engineers all the time. So, how do you see registers being used in typical designs?
So these registers are responsible for configuring the system and also communicating the status information back to the host. So these are all over the place. In each IP, you would have these registers.
Yeah.
So these are typically accessed by a register bus. Could be AMBA or OCP or Wishbone or any even proprietary bus.
Okay.
A lot of our customers use AXI, APB, AHP, buses like that.
Okay, so in my experience, we have a big mishmash of ad hoc tools and formats we use to manage all of this. People use spreadsheets, text files, backs of napkins, Big Chief tablets, and crayons. Wait, never mind about that. Keeping track of all that register stuff doesn't seem to be built into most EDA tool flows.
Well, that's where we come in. Typically, architects, design engineers use different formats, like you said. Word, Excel, OpenOffice, FrameMaker, even proprietary formats. Often we see people using their own custom formats. And that's okay. And also there are industry standards like SystemRDL and IPExact, but they could be all over the place.
Sure. So during the design process, it's hard to keep everybody current as the design evolves. Let's talk about those customers on that slide.
Right, so this register information is used by everybody in the development team, starting from hardware designers who need the synthesizable RTL, hardware verification, typically using UVM, and many development teams needing the C++ header files. They're also used for lab debug, diagnostics, and even technical documentation.
Okay, so let's get in a bit more about how these consumers use this register information.
Well, design team will need it for implementing the RTL. They will synthesize the register and, create target FPGA or an ASIC. Verification team will need it to verify those registers are actually operational. The device driver people would actually need it for creating the device driver so that they can talk to the hardware. And similarly, the firmware and application software would also need to talk to the hardware.
Sure.
Lab debug people need it for finding out whether the FPGA or the ASIC is behaving correctly in the lab. And similarly for the diagnostics people. And of course, technical documentation, you have a lot of consumers of technical documentation. Everybody in the team needs proper documentation of that registers. Maybe your end customers, maybe those are outside your company. They would need the technical documentation as well.
Right. Anupam, before we dive into the details of how to solve all of this register mess, give me a quick high-level overview of Agnisys solutions.
Okay, we started out with IDesignSpec about 10 years ago.
Okay.
So it's been a long time.
Yeah.
And we have seen all kinds of issues and stuff from the customers and, kind of rolled into the product. So IDesignSpec is available in several different flavors like Batch, Word, Excel, Cal. That's our flagship product being heavily used in the industry. And then we have what is called automatic register verification. So we develop the entire UVM test bench, all the sequences, the verification plan. All you have to do is click a button.
Nice. Okay.
And we can do automatic register verification using simulation or formal. So we generate properties and assertions. We have also added IDesignSpec because we saw people struggling with how to program these registers.
Okay.
Specifying registers is one thing, but actually programming them.
Right.
Often that information is embedded somewhere in the design specification.
Right.
And that too has to come out. It is good to bring it out in an executable form so you can generate other stuff from it.
Right.
Just like we did for registers. And then we're using IDesignSpec at enterprise level. And so IDS Enterprise caters to big teams using IDesignSpec with different input formats.
Okay, so we've discussed the problem with register information. Let's dive into that big blue IDesignSpec box and talk about how Agnisys helps me solve these issues. So, what exactly is the IDesignSpec suite?
So, IDesignSpec is the add-in into Word and Excel.
Okay.
And those add-ins allow you to create the specification, which is correct by construction.
Okay.
So the add-in will take care of overlaps and downstream problems. Using the add-in, you can create your register specification. The dark blue box is the generator.
Okay.
Which will create the various outputs shown at the bottom. Now, the interesting thing is within this editor, you can either import all the standards and custom files into Word and Excel, but you can also reference them.
Oh, okay.
Yeah, so not just import them, but also reference these other files. So what that means is one IP could be in system RDL, another IP could be in IP exact, and you can refer to those files.
Right.
And then generate the output as well.
Nice. Okay, so the Word and Excel stuff we're already using can be rolled into the IDesignSpec flow. Tell me more about that.
The Word and Excel can be consumed on a Linux system. It doesn't have to be sitting on a Windows machine, but you can actually generate outputs using IDS batch. And on a Linux system in a make-based process and generate all the things at the bottom. In fact, a lot of our customers are using that flow. They use Word or Excel as a front end, and then on a Linux system, they generate the outputs. And the reason is a lot of functional specification work is still done on Windows machines.
Yeah.
And the development and the design and the verification is done on Linux boxes.
Sure.
So that's why we have this whole suite where the files will work on any platforms.
Okay, good. So let's dive into the verification side of things a bit. Now, most teams these days are using something like UVM, right?
Many teams are using UVM or adopting UVM in large numbers.
Sure.
So, one of the challenge is for a new team how to use UVM. Creating register model is just the start of the journey for a verification engineer. Once you have the model, what do? You have to integrate that in the rest of the test bench.
Right.
And actually, in order to solve that problem, what we've done is create ARV, which basically generates the entire test bench.
Oh, okay.
And it will generate the sequences, it will generate the tests, it will generate the environment, even the verification plan and the makefile. It's ready to use out of the box UVM based environment, which integrates the UVM reg model with your design under test. And basically you run the make and you would see the results. It's got a very intuitive report capability as well.
Okay, so obviously we don't have time to go through everything IDesignSpec can do. That would be possibly the world's longest chalk talk. But if people want to dive into more detail, they should click the link right here in the presentation. But can you give us a quick virtual demo to get a feel for the basic flow of IDesignSpec?
Yes, sure. So I'm showing here the Word implementation. Like I said, it's an add-in. The add-in basically creates a toolbar, which enables you to create the specification. With this, you can create a hierarchical specification. So you can create a chip. Inside a chip, you can have blocks. Inside a block, you can have a reg group or a register. A reg group can have other reg groups, and so on. You can create enumerations. You can create memory. You can create FIFOs. A simple Word document is transformed into a specification, which is executable.
Right.
We can generate stuff from it. These templates, I can click on a register, I get a register. I can add a specific address, I can add the fields. Software access means how the host is accessing these register fields. Hardware access is how the application logic is accessing it. And then the default values. And of course, you can put in the description and other properties associated with those fields.
Okay.
And this is how the specification would look like. Once you're done, you would have a bunch of registers and you would have blocks, and you can even refer to external documents.
Okay, cool.
The specification would look like this. And you click on check or generate, and a check process goes. The tool does address calculation and actually it back annotates the information onto the spec.
Okay.
You don't have to edit it in multiple places.
Nice. Okay.
It will insert the table of content, the addresses, the default values. It will do all kinds of consistency checks like detect overlaps in bits, register fields, blocks, or reg group. It will also check for incomplete data or bad or incorrect data. The idea is that you have a specification that is correct, and you would not get any issues downstream. As you can see, it is very convenient. It doesn't require any learning curve.
Yeah.
It's like simple. You click on a register, you enter the information.
Nice. Okay, so how do I tell what I want it to generate?
Right, so then you click on the configure, and then you choose all the outputs that you want.
Ah, okay.
So it's a simple, just select that, and that would be stored in the document. Because this is part of the document, you can send it to somebody else who doesn't have our tool. They can also open it. It's a normal Word document.
Yeah, that's great. Okay, so does IDesignSpec support any other input formats?
Absolutely. So we support Excel. Oftentimes people use Word as a starting point, but sometimes you have very large number of registers and you want to use the power of Excel.
Sure.
And so we support Excel based templates, and these templates are highly configurable. As you can see, you can specify what these headers are in a meta file.
Okay, so what about system RDL and IPExact?
Absolutely. So these industry standards we absolutely support. With IDS batch, you can just generate outputs using system RDL and IPExact. And also, like I said earlier, you can import into Excel or Word, or you can refer to them, both. So we definitely support system RDL and IPExact.
Okay, so what does my generated RTL design look like?
The generated RTL design is quite straightforward. You have the register bus on one side, we call that a software side or the host side, and you have the application logic on the other side. And you have the decode logic, internal registers, and the readback mux. And we have a capability where you can mark something as external and specify the RTL implementation.
Ah, okay.
So that makes it possible for custom registers to be included.
Excellent. So what gets generated for my UVM process?
Right. So far we've talked about RTL. For UVM, we not only create the UVM classes, but also the coverage model, the constraints, and the HDL paths.
Ah, okay. Now, if I could interrupt just a tad, what about properties? How do I specify those?
Properties can be specified depending upon the input format that you choose. In Word, you can either add a row to your template, or you can use curly bracket and add a name equal to property.
Okay.
Or you can use curly brackets to include a name equal to value. In Excel also, you can have either a column for property, or again, you can use a curly bracket with name equal to value. We've also extended system RDL with UDPs to add additional properties.
Okay.
And for IPExact, we have created vendor extensions to include additional properties.
Cool. Okay. So we've kind of covered the basic features of IDesignSpec. What about some advanced features?
Yes, I think IDesignSpec has grown over the years based on customer inputs. People have requested us various features, and one of the things we do is not charge anything additional.
Nice. Okay.
We incorporate those features in the tool in order to make it more powerful. So over the years, we've added these features like dealing with multiple bus domains. You could have a block where you have multiple bus domains coming into the block in an SOC system.
Yeah.
And we do this multiple bus domain in all our flavors like Word or Excel or System RDL or Ralph.
Nice.
Parameterization is generation of, say, RTL or UVM in a format that is parameterized. Interrupts, I already talked about. There are various ways of creating interrupts. One of the good things is if you use IDesignSpec, the interrupts are all systematic.
Oh, okay.
Because your entire team follows the same nomenclature of those interrupts.
Right.
Then we have datasheet generation. Datasheet is becoming an important aspect. People want to have customized datasheet for the registers.
Yeah.
And we really shine in the quirky or the custom or the special registers. Various types of special registers.
Yeah.
It's possible to generate various types of special registers.
Okay, Anupam, if I want to run things batch, a lot of times I want scripts or make files to do the repetitive work for me.
Right, so you don't want to always sit there in front of Word or Excel and generate stuff. Often you may want textual input formats, or you want to process the Word or Excel file in a batch form.
Sure.
And so IDS Batch will run on all platforms. You can make it part of Make, or you can have it in your grid engine, or you can run jobs in parallel and generate exactly the same outputs as you got from Word or Excel.
Nice. Okay, so we could go on all day into more in-depth details, but I think we're out of time. So quickly, before I go, a lot of people don't know about Agnisys as a company, but you guys have been around for a while and have some really big customers. So tell me where all of this technology is coming from and where it's going.
This is our 10th year of operation, and we have been profitable and we're privately held. Our headquarters are in Boston, and we have more than 500 users worldwide. And we're very proud to say we have more than 30 customer companies that are using our tools. And we have a high customer retention rate because once people see the ease of use, they just stick to it.
Nice.
And we have R&D centers in US and India, and support centers in Boston, San Jose, and Noida, India.
Okay, so tell me about what kind of companies are using your solutions.
So there are all kinds of companies. Anybody creating hardware design or anybody creating configurable hardware design uses us. So we have companies like system development companies, chip development companies, defense contractors. We also have consulting companies because they want to speed up their development as well.
All right, well, I think that's all I have time for today. Thank you so much for joining me, Anupam.
Thank you, Amelia, for having me here.
And before we go, you didn't forget to click that link, did you? There you can find out even more information about IDesignSpec from Agnisys. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, check out the Chalk Talk section of eejournal.com or head on over to YouTube, keyword EEJournal.